Alright guys, so continuing the previous video, we're going to look at another way to do 3 by 3. Then I'm going to tell you how to do 4 by 4s and larger matrices, how we extend the cofactor expansion. And then we will talk about how to make it easy, quote unquote, using our row operations. So the shortcut method for 3 by 3, you may be familiar with it from computing cross products or from cross products. That's where you would see it. And the way you do it is you just augment your matrix by the first 2 columns, and then you take all the diagonals of length 3 and you multiply all the entries within them. So if you multiply here 1 times 1 times 2, you get 2. Let's write it in this color. You get 2. When you multiply here, 2 times 3 times 3 is going to be 18. And when you do 1 times 0 times negative 1, you get 0. So when you go in this, what would be northwest to southeast direction, you're going to put pluses for it. And now we're going to go from northeast to southwest. And we're going to do the same thing. We're going to multiply all the entries. And we're going to do it in such a way that we're going to grab only the diagonals that include 3 entries. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And so now you multiply 2 times 0 times 2. That's going to give me a 0. And I think I'm going to write it here. Then you're going to grab 1 times 3 times negative 1 is going to give you a negative 1. Negative 1? Who doesn't know how to multiply times 3? Me. So you get negative 3, sorry. Oh, I smudged it all over. There, that's better. All right, and then you multiply the last one. 1 times 3, positive 3. Now, to these terms, you're going to assign a negative when you're going in this direction. So minus, minus negative, plus, minus this. And that sum, whatever you obtain, is going to give you your determinant. Of course, you don't have to write it into rows. I just wrote it so we could keep it somewhat organized. And we get 2 plus 18, 20, plus 3 minus 3, 20. So we verified that the answer we got in the previous video is correct. Look at us, we know how to do linear algebra. Good for us. So now let's talk about 4 by 4 matrices. So what happens when you have a matrix that is 4 by 4? Let's put a lot of zeros just because we don't want to be dealing with too many calculations, but then let's just throw in numbers as we may. You know that I only know numbers from 0 to 4 and the negatives, and only integers too. Sometimes some rationals. Makes things easy. All right. So now, how do we do the determinant for such matrix? All right, so we're going to do the same thing we did before. We're going to grab a row, and I hope I convince you that you want to choose a row that has a lot of zeros, or as many zeros as you can. So obviously, I'm going to grab this one, because that then gives me 2 possible entries. The formula will be similar, or pretty much the same, as what we did for 3 by 3, except we're going to be increasing by 1 entry. So you're going to grab this 1. You're going to put it here. And you're going to multiply times negative 1 to the power of 1 plus 1. 1 plus 1 is the 1 comma 1 entry. Gives you 1 plus 1. And then the determinant of the matrix A when you eliminate your entries 1, 1. Okay? Same we did before. Then plus 0 to the power of negative 1 to blah, blah, blah. But it's 0 times the determinant of A1 to tilde. 0 is going to cancel it out, so I'm going to just go to the next one. Plus 1, so I'm going to grab this other one. I completely ignore the zeros just because they don't add anything at the end. So I'm going to do negative 1 to the power of, what entry am I in? I'm in the entry 1, 3, so 1 plus 3. Determinant of the matrix A tilde 1, 3. Alright, so what I need then is the determinant of the matrices that I obtained by eliminating the first row and first column. That's going to be my A1, 1 tilde. So A1, 1 tilde is the matrix where I have the entries 2, 3, negative 1, 2, 1, 3. I told you I don't know many numbers. 1, 2, 1. And then my matrix A, I'm going to write it down here so I have space for the calculation. A1, 3 tilde will be the matrix where I eliminate, the matrix A where I eliminate the first row and third column. So now I'm going to be eliminating this one over here. So let me grab my blue marker. I'm eliminating this one over here. Okay, so what am I left with? 1, 2, and negative 1, 4, 2, 3, and then 1, 1, 1. All right, so now I need to compute those determinants. This is going to be 1 and 1. It's all good. One thing I wanted to mention, some people don't do the signs here, the negative 1 to the 1 plus 1. The way they deal with it would be just drawing the matrix. Let's see if I can fit it. Yeah, they draw the matrix. They start with a plus, and then they alternate signs like a checkerboard or chessboard, if you will. Am I still there? Yes. And then they just use the signs. Notice that I chose this one and this one, which are plus and plus. Notice I'm going to get the plus sign from this one. This is going to be a positive 1, so it's going to be plus. And this one is going to be also positive 1, because it's going to be negative 1 to the fourth. Negative 1 squared, they're positive. Now, the terms in the middle would have given me a negative sign. So you can ignore this term and just grab your signs from this matrix. If you prefer that, that's perfectly fine as well. So to obtain these determinants, they're 3 by 3. So I could do another cofactor expansion, or I can do the shortcut method, which I'm going to choose because it's easier. So we always try to do things easier. And I used to say in class, well, we do this because we're lazy. Until one day it came up in my faculty evaluation. Somebody said, he's lazy. He said it in class. And now I'm saying it on YouTube for the whole world to know. And it was not that. I was just trying to teach them how to do things efficiently. So now we're going to do this not because it's easy, not because we're lazy, because it's more efficient. There. So you'd make of that what you will. All right, so let's go ahead and multiply in the diagonal. So we get 2, we get 3 times 1, so plus 9. I'm adding 9s in this direction. Negative 1 times 2 is going to be negative 4 with a positive sign. Negative times positive is still negative. And now I'm going to go in the opposite direction. I'm going to do 3, 2, 6. Now put a negative in front. 3 times 2, 6 times 2, 12, so negative 12. And then negative 1 times 1 is going to be negative 1, but with a negative sign, positive 1. So I changed the sign of each one of them because I'm going in this direction. So I got 6, negative 12, positive 1. And now it's just a matter of adding it to find our determinant. By the way, this is terrible. I should have put determinant here because I'm computing the determinant, not just the matrix itself. All right, and so here what I get is going to be 11 minus 4 is going to be 7, minus 6 is going to be 1, plus 1, 2, minus 12, so negative 10. Let's check again because I think I got lost at some point. So negative 11 and 11 just cancel out. Negative 10 works out well. All right, so now let's do this one again. So by the way, this first entry, which is the 1, 1, I already found it is 1 times negative 10, so I get a negative 10. I just got to find this one to get my determinant. So let's do that. So you multiply in that direction. 1 to 1 is 2 when you multiply. 2 times 3 times 1 is 6. Negative 1 times 4 times negative 1 is negative 4. They are all added. So we go back in the opposite direction now. 2 times 4 is 8, so negative 8, because we're putting negatives in front. 3 times 1 times 3 is 3, but with the negative in front is negative. And negative 1 times 2 is going to be negative 2, but negative plus 2. So what do we have? 2 and 2 and 4 cancel. I get 6 and negative 2 is negative 2, so negative 5. I'll do it again just to be sure. Let's see. And by the way, if you're not in my class and you're watching this, you may drive your professor crazy by doing it this way. Just put an equal sign so you continue having equalities and you can pretend that you're doing things properly. Don't tell him you watched me. So let's see, here we get 0, negative 4, so negative 7 plus 2, negative 5. Correct. So then we put that in here. And you get that your determinant is negative 15. So that's how you want to do 4 by 4s. Now guess what? If you want to do 5 by 5s, same expansion, but now your determinants, your a tildes are going to be 4 by 4. So you have to do another cofactor expansion. When you get to 3 by 3, please do the shortcut method because that would make it way too complicated. But now, if you have a 5 by 5 or a 4 by 4, I do not recommend you do cofactor expansion. At that point, you want to do row operations to compute those determinants. All right, guys, so apparently I'm unable to fit all the content in one single video. So the other video is already getting, the video is already getting a little bit long. So I'm going to stop here. I want to create, the last video will be how to use row operations to compute a determinant. So that's going to be useful when you have larger determinants. So I'll stop this video right here. Thank you for watching, and I'll see you in the next one.